Let's take a look at an example. I'd like to use the table below to find the values for parts A through C. The table given gives us time in seconds as our input, and we have 0, 3, 6, 9, and 12 seconds, and distance in feet, and we have 0, 10, 19, 25, and 30. Suppose I'd like to find the average speed from t equals 0 to t equals 12. Again, I'm computing something equivalent to the slope. So I will do delta y over delta x, which in this problem, delta y would be the change in distance, and delta x, as you would think of it, is the change in time. So we're going to do change in distance over change in time between t equals 0 and t equals 12. So change in y would be 30 minus 0 over 12 minus 0, or in other words, 30 over 12. If we wanted to, we could pull out our calculator and we could actually get a decimal approximation, which would give us 2.5. Now the one thing we should remember to do is to put the units on. Since x and y mean something to us, we should put the units. The units will be, again in fraction form, with the units of y in the numerator and the units of x in the denominator. And if we do that, we get feet per second. So the average speed between 0 and 12 seconds would be 2.5 feet per second. Now suppose I wanted to find the average speed from t equals 0 to t equals 6. Well, first thing we'll do is find those values in our table. So 0 we've used before, and there's the 6. And again, we'll do delta y over delta x. And so let's see, our y's are 19 and 0, so 19 minus 0. Our x's are 6 and 0, so we get 19/6. Now ordinarily when we do a problem, if the fraction doesn't divide out into a nice form, you'll probably find that you will just leave it in the fraction form, because this right here is only an approximation, and so I'm going to use the approximate symbol of 3.17, and again feet per second would be our units. And then part C, find the average speed from 6 to 12. Again, we're going to find those values in the table. So here's 6, here's 12. Again, change in y over change in x. So this time it'd be 30 minus 19 over 12 minus 6. If we do that, we get 11 over 6. Again, if I divide that out, I'm going to get something that's not particularly exact, right? It's going to be approximately 1.83 feet per second. So what I could actually notice is between 0 and 6, I'm going about 3.17 feet per second, and 6 to 12 is 1.83. So this object is actually slowing down as time progresses, but its overall speed would be on average 2.5 feet per second. Now, one of the questions that you often get asked is, how would we indicate those results on a graph? Well, remember, average rate of change is the same as the slope. So what I would be doing is I would be looking at the slope at various parts on the graph. So if I were to do 0 to 12, what I would be looking for is the slope of the line joining these 2 points. And I'll do my best line draw here. So this the slope of this line is what I get for A. When I did the 6 to 12, actually I did 0 to 6, so if I did 0 to 6 as my B, that slope of that line is the answer I had to B. And then 6 to 12, that would be from here to here. That's what I got in part C. Now, if I were actually answering that as a question, I'd probably be a little more specific than just writing slope equals B and slope equals C. But what you should know is when you compute the average rate of change, you are computing the slope of a line joining 2 points.